That was a fairly half-hearted response. George, good evening, everybody. Far, far more impressive. Welcome to our Gresham College lecture here at Conway Hall. My name is Richard Smith. I'm the director of the college, and it is my absolute pleasure to welcome you here today. Although I do understand from those more informed about astronomy than I that the title of this evening's lecture is essentially an astronomical invitation to a barroom brawl, but hopefully we'll be able to keep it all in good spirits. Very quick couple of housekeeping announcements. Can I just quickly ask, can you wave to me if you're here for the first time at a Gresham College lecture this evening? A particular welcome to you. We have been awaiting your arrival for over 400 years, and now we are complete. So it's lovely to see you. So particularly for your benefit, so what you're going to be having this evening is a wonderful, inspirational, educational, informative lecture for about 45 minutes or so. And that's going to be followed by a time you can ask some questions. You have two ways of asking questions. You can wave, in which case please wait for the microphone to arrive with you before you ask your question. Otherwise, those watching at home won't be able to see. Or you should have on your seat one of our termly little leaflets, and that's got a QR code. If you scan the QR code, it should take you to a website called Slido, and that will, by some form of astronomical endeavour, send your question to my tablet, and I can ask it on your behalf. Final piece of housekeeping, you will be very pleased to know that we have not planned a fire alarm for this evening's lecture. So if the fire alarm does go, we're all doomed. Do head out the signs that conveniently say exit, and you'll be guided into the right direction. Right, I think that's enough housekeeping for today. Let's get on to the main event. So our speaker this evening is Professor of Astrophysics at the University of Oxford and a research fellow at New College. He was the founder of the Zooniverse citizen science platform, which provides opportunities for more than 2 million online volunteers to contribute to scientific research. And he's perhaps best known for presenting the BBC's long-running Sky at Night programme. But for us here at Gresham College, he is the 38th Gresham Professor of Astronomy. Please join me in welcoming Professor Chris Lintott.
Thank you. Thank you all. Thank you. Thank you very much for coming. It's a rather warm night to be discussing the edge of the solar system, but never mind. We'll see if we can get the appropriate atmosphere. My message tonight is simple, which is that Pluto isn't a planet. Thank you. Excellent. Good. I haven't been booed at a lecture since I stood on stage at Jodrell Bank and told 20,000 people at a music festival that aliens didn't exist. So that was a rapturous welcome. If you're going to blame anyone for that, the traditional route is to blame the International Astronomical Union, who were seen here in 2006, 24th of August 2006, so nearly 20 years ago, defining officially for the first time in human history what a planet is and isn't. And as you can see, this was a fairly shambolic affair. It involved a small proportion of the world's astronomers waving pieces of yellow cards with different degrees of enthusiasm, as you can see here, at the end of 2 weeks of debate about this pressing issue. Now, for many of the astronomers in the room, though the debate had taken account of the fact that it was felt that they needed a definition that would be broadly acceptable to the general public, these people mostly, from talking to them, I know, felt they were having an academic debate in a scientific conference. And so it was a complete surprise to them that scenes like this were broadcast live around the world, and that headlines such as Pluto loses status as a planet quickly spread around the globe. And in fact, there were protests. This one here is at New Mexico State University, and perhaps we'll give a prize later for anyone who can tell me why there in particular. As you can see, this is a topic that doesn't always endanger scientific responses. And even the BBC News article, I love this at the end, says, this is written from Prague, where the International Astronomical Union was meeting. There is a recognition that the demotion is likely to upset the public who have become accustomed to a particular view of the solar system. At least one friend in the audience was threatening to come tonight in a Justice for Pluto t-shirt. I learned as a kid a mnemonic about planets. For me, it was many vampires eat Mars bars up near Pimlico. Of course, that's ruined by P disappearing. And another friend in the audience is currently having an argument with her young son who saw an old episode of the Magic School Bus and now thinks that she lied to him about the number of planets. This has even become a political issue just in the last few months, where NASA's new chief, Jared Isaacman, gave an interview to the Daily Mail saying he wanted to make Pluto great again, and followed this up via testimony in the US Congress, where he said that NASA was taking steps to make this happen, though he didn't explain what those were. I thought this was brilliant because this makes this lecture topical. So, what I want to do this evening is explain to you really how we got into this mess, tell you a bit about Pluto so you can make your own minds up, and then I will, at the end, try and justify my very firmly held view that this isn't one of the planets in the solar system. But the story really has to begin with the discovery of Pluto, or actually has to start nearly 2 centuries earlier with the discovery of Uranus, seen here in a beautiful recent images from JWST in the infrared with the 7th planet and its beautiful rings there. And on the right, discoverers William and his sister Caroline Herschel, seen in the act of polishing a telescope mirror, but who would go on to discover Uranus from this country. So Uranus is the British planet, and its name is our fault, although not Herschel's. He wanted to call it George, which I think would have been an improvement. Now, planets are, to a certain kind of astronomer, simple things. They move around the sun because of the sun's gravity, or rather because of the mutual attraction between the planet and the sun. And it's easy to calculate the laws of motion so that you can predict where a planet should be over time. What you have to do is you have to watch it for sufficiently long in the sky that you can track its motion against the stars, you can deduce an orbit, which is mathematically tricky but doable, and then you have a prediction as to where it should move. And it was realized fairly early on that Uranus wasn't quite moving as it should do. If you took into account the gravity of the sun, and then if you tried a bit harder and took into account the gravity of Jupiter, the next largest thing in the solar system, and even the other planets, Uranus was very slightly off its path. And so pretty quickly in the late 18th century, astronomers realized that there may be something else out there, another body whose gravity would be perturbing Uranus, pulling at it. Several astronomers reached this conclusion. In this country, John Couch Adams in Cambridge, a young astronomer, did some calculations, worked out where he thought this new planet should be, wrote to the University of Cambridge, to the Astronomer Royal, and to his university observatory. And eventually, after many letters, they started to look systematically for the planet, though they didn't notice anything amiss. We now know that it was actually observed from Cambridge by Professor Chalice, who missed the chance to make a discovery, because on the continent, there was Leverrier in France had made similar predictions. He wrote, actually the French didn't take him seriously, but he wrote to Berlin Observatory, where this man, Johann Galle, in 1846, set to work to find this missing planet and found it on his first night, recognizing it as a planet because it was a disk rather than a star in the sky. And to some extent, he was lucky. This plot gives you in degrees all the predictions. In blue, various predictions made by Adams, but you can see that in the pink square is Leverrier's prediction, and Neptune was found pretty much right next door, just a degree or two away. So that was 1846. We've now found another planet in the solar system. There was much rejoicing. And again, people watched Neptune's movement and looked at the movement of both Uranus and Neptune and tried to do the same trick again, tried to see whether there was anything out there that was perturbing the orbits of these new outermost planets. Now, this is a slow process. Uranus goes around every 84 years. Neptune completes an orbit of the sun every 165 years. So we're just over 1 Neptune year since its discovery. But as the observations mounted up, and in particular because people found older observations, pre-discovery observations of these planets, it became apparent that Neptune too was misbehaving. Amongst the first to point this out was this guy. This is Jacques Babinet, who's sort of magnificently French. pioneer of optics. He actually, despite his gruff appearance, actually spent a lot of his career studying rainbows, trying to predict that, which I just enjoy as a contrast. But he wrote in 1848, so just 2 years after Neptune was discovered, that there must be other planets out there. In fact, he thought Neptune wasn't massive enough to cause the observed irregularities in Uranus's motion. And this sort of argument caught the eye of somebody we've met in these lectures before, the great American philanthropist and amateur astronomer and funder of astronomy, Percival Lowell. Now, Lowell spent most of his time advocating a search for alien life on Mars. That's why I've talked about him before. And he founded a great observatory on Mars Hill in Flagstaff, Arizona, to look for these things. But he got interested in this idea that there might be other planets out there. And he also argued that by counting the shooting stars, the meteors that you see in the sky over the course of the year, that some of the patterns, the fact they come in showers, might suggest that they too were being perturbed by some unknown outer body. And so he thought he could calculate where in the sky this planet would be. I like Lowell a lot. He was an enthusiast, a great lecturer, and not a man ever blessed with a lack of confidence. And so in his article, in which he tried to persuade people to go looking for this new planet, which he called Planet X, he said, "It may seem strange to you to speak thus confidently of what no mortal eye has seen, but the finger of the signboard of phenomena points so clearly as to justify the definite article. The eye of analysis has already suspected the invisible." And so I hope I can point the finger of the signboard of phenomena towards truth for you this evening. Now, Lovell died in the early 20th century. He didn't live to see Pluto, but it was an astronomer at his observatory that made the discovery of what became the 9th planet. It's this guy. This is Clyde Tombaugh, pictured just after the discovery back on his family farm with the telescope he used essentially as a boy and in his early 20s. We're back in the 1920s here. He learnt to study the sky through this telescope and to make sketches, and he sent them to Vesto Schleifer, who was running the Flagstaff Observatory. They corresponded. The quality of Tombaugh's observations, and in particular of his drawings, got him a job as an observer at Lowell, and he arrived at the observatory when he was 23. He was set an incredibly tedious task, which was to search for this planet using the newfangled technology of photography. How this would work is he would use one of the larger telescopes on the site. When the moon was out of the way, so that the sky was dark and you could see the faintest objects, he would take 1 hour long exposures of the sky using photographic plates. And on an average one of those plates, there was something like 300,000 stars. And then he'd do the same thing a month later, so new moon to new moon. He'd go back, take pictures of the same part of the sky, and then when the moon was up, every other night of the month, what he would do was blink between the two to look for something that was moving. So most of the 300,000 stars would stay in position. He was looking for something that moved. In February 1930, he was looking back on the previous month's observations. He had about a month's backlog, and he noticed one of the stars in this frame, that one of the stars in this frame, was moving. What was even more important, so it's the one labeled with the arrow, though the arrow was added later. Otherwise, this would be easy. It's much easier now. He realized not only was it moving, but it wasn't moving very much. And so that told him that it wasn't an asteroid whizzing around between Mars and Jupiter, but was in fact a distant and new planet. And he said a thrill came over him as he realized this could be the most important discovery of his life. And he looked at his watch so as to record the time that he made a momentous discovery. Now, luckily he'd caught it only a month after the observations were taken. They were able to go back, find it again, and see that it was indeed a real object, and they could calculate the orbit and show that it was in the outer solar system, about as far away as Neptune is. And less than a month later, on March the 13th, 1930, deliberately chosen to be 149 years, or about 1 2/3 Uranus years, 149 Earth years after Uranus was discovered. And they put out a press release, and it hit the press. So here's the New York Times. It is the headline. Ninth planet discovered on edge of solar system, first found in 84 years, lies far beyond Neptune, and sighted January 1st after 25 years search begun by the late Percival Lowell. What's interesting is if you zoom in, they have this info box, which is the new planet compared with Earth and Neptune. I suspect that's quite hard to read from out there. So it says size, Earth, 8,000 miles in diameter, Neptune, 32,000 miles an hour in diameter, new planet, 8,000 or more. So they're saying it's Earth-sized. They say it's rotating 1 to 2 miles a second, which is slow, that's like Neptune. And they say it takes 300 to 600 years to go around the sun. But there's no doubt here, and they note that these figures are tentative, but they're based on what the astronomers at Flagstaff have told them. There is zero doubt here that what they found is a large planet in the outer solar system. It must be big, because otherwise, how is it affecting Neptune's orbit? So it must have enough mass to be a significant gravitational pull on Uranus and Neptune. That's how they found it. They went looking in the part of the sky where such a planet should exist. And so this fitted in a long tradition, then at least 400 years old, of astronomers changing their mind about the number of planets. So one can argue, I think, in antiquity, for most of the time there were 7 planets. If you've got a geocentric view of the universe, there's the Sun, Mercury, Venus, the Moon, Mars, Jupiter, and Saturn. Once you get into sort of the heliocentric solar system, you realize that there are 6. The 5 that we can see with the naked eye, Mercury, Venus, Mars, Jupiter, Saturn, and of course our own Earth gets added. Then we find Uranus, so we have 7. And then Ceres was found, the largest of what we would call the asteroids that sits between Mars and Jupiter. That's 1781, so we've now got 8 planets. They then find Vesta, Pallas, and Juno, the next 3 asteroids. So in 1807, we have 11 planets. Then Astrea, which still looks like a dot. That's the best photo we have of it today. It's found, so we've got 12. Neptune makes it 13. And then just a few years after Neptune was found, they found 50 more asteroids. So they realized that the space between Mars and Jupiter was full of small rocky bodies, most of which were no bigger than a few hundred meters across. They became known as celestial vermin, or more politely, as the asteroids. And so people decided that, okay, we'll invent this category of asteroid, relegate all these small things into it, and we'll go back to having 8 planets. And then, of course, 1930, we have 9. So with that slight detour around asteroids, we've been slowly expanding our knowledge of the solar system. Just makes sense that Pluto is a planet. I should explain, by the way, there's a great story, which is slightly apocryphal, but was reported at the time about the name, which was that New York Times announcement didn't name the planet, it just said new planet. And they asked, or at least they received, thousands of suggestions from members of the public as to what to call this planet. And one of the people who suggested Pluto, and the person who got credit for this, is this girl. This is Venetia Burney, whose grandfather was Bodley's librarian in Oxford at the university, and she suggested that it should be called Pluto, after the god of the underworld, but also because PL, of course, is Percival Lowell, the founder of the search. So it's a nod. As we'll see, this becomes a theme. This is the original search. So this is an 11-year-old who named the planet, and she was credited in the press. I'm mentioning her partly because it's interesting to see where the name comes from, but also because one of the favorite things I've ever done on the BBC's Sky at Night is that about the age of 80, we took Venetia to the old Greenwich Observatory in Herstmonceux because she'd never seen Pluto. And we thought it would make a lovely bit of television to have her see Pluto for the first time that she'd named all those years earlier. And it's a clear night. We got one of the giant telescopes pointed at a patch of sky. No arrow, remember, so it's hard to work out, but we got it centered in, and we're pretty sure we got Pluto in the center, and it just looks like a star, even in a large telescope. Just looks like a star, but it's still Pluto. It's still exciting. I'd never seen it before. It was nice to tick it off. And she looked through the eyepiece on camera and turned around and went, "Is that it?" And the presenter went, "Yes." And she went, "Well, that wasn't worth the effort, was it?" So she might be the patron saint of this lecture. Nonetheless, at the time, people were excited. Pluto quickly distinguished itself as slightly odd. For starters, Clyde Tombaugh went back to looking for things in the outer solar system, and for the next 13 years, breaking only to go and get a degree from the University of Kansas, which one imagines having found a major planet they gave him pretty easily, he looked at, over 13 years, 90 million stars, but only one Pluto. He didn't find any more bodies out there. Pluto's orbit was determined, including crucial older observations from Belgium and from various observatories in the States. And this is the orbit here in pink. And there are a couple of odd things about this. So it takes about 248 years to go around the sun. But for 20 of those years, it's within the orbit of Neptune. So from 1979 to about 1999, the furthest planet was Neptune. Now, the two are in a resonance, so Pluto completes 2 orbits for every 3 that Neptune completes, so there's no chance of a collision. But there's this sign that Neptune has influenced Pluto's orbit. And then the other thing that you can see on this diagram is that unlike all the other planets, which orbit pretty much precisely in a plane, that's what gives us the zodiac on the sky, Pluto has an eccentricity, so it goes up or below the line of the solar system. It's an unusual feature. And these unusual features began to get people, even contemporaries of Tombaugh, people responding to the discovery, to start arguing that maybe this was something different than the other planets. They also had other problems. Even Schleifer, Tombaugh's boss, reported on a couple of oddities in a bulletin that was released later in 1930. For starters, he said that the planet wasn't bright enough to be massive. He said, in fact, that if you took Mars out to the distance, about 40 times further from the sun than the Earth is, then Mars would be about the same brightness as Pluto. Now, he's wrong about that, but it gives you an idea. So he said, so therefore it's probably about Mars size. So we've gone down from bigger than the Earth to Mars size. And then the other thing that's odd is in this plot, so these are just measures of color. You can think of it as how on the axis at the bottom here, this is how red something is. So the further right you are, the redder you are as a planet. And this is a measure of infrared color. So this is just called a color plot. You see Mars is in the top right, very red. The other planets are in the middle there. And Neptune and Uranus, the things we know exist in the outer solar system, well, they're down here on the bottom left. And so you'd expect if Pluto was a planet like Uranus and Neptune, it should be down here in the bottom left. It's not. It's sort of the same color as Jupiter, a sort of creamy white color. And so people said, well, this can't be a massive planet. You found something else out there. But the observations of Uranus and Neptune seemed real. Something must be perturbing them. It might be Pluto. So there's some debate in the middle of the 20th century. What really happens, though, is that people start arguing that there should be more things out there other than Pluto. And that starts with a theoretical argument. So if we think about how stars and planets form, well, stars form in nebulae like this one. This is a Hubble Space Telescope image. This is an area of the cosmos that's cold and where the dust and gas is isolated from its surroundings. There should be a movie, but I don't think that's going to play. Never mind. Within these cold regions, gravity is able to take control and material collapses under its own gravity until you get to the point that you form a star. And then around a young star, you get the leftover material which forms a disk. And these are real observations of planetary disks seen with ALMA telescope high in the Chilean Atacama. And in these particular young stars, you can see there's sort of these gaps developing in the disks. Well, those are places where newly forming planets, which are coalescing out of the dust and gas in the disk, they're forming and they're absorbing the rest of the material from the disk. So we know that these are places where planets are forming, and we have a good idea of how this process works, at least at the top level. Now, as this theory was being worked out, people started to speculate about what would happen on the edge of these disks. And in particular, there's an Irish astronomer, an amateur, called Kenneth Edgeworth, who thought about where comets come from. Now, comets are icy bodies that come from the outer end of the solar system. This is Churyumov-Gerasimenko, which was visited by the European Space Agency's Rosetta probe. And the bottom left is the orbit of the most famous comet of all, Comet Halley. And you can see it swings into the inner solar system and then back out again. It's about as far from us as it ever gets right now. And Edgeworth was thinking about these things, and he said, thinking about how these things form, he said he had not so much a theory, but he had an outline of a theory with many gaps remaining to be filled. And he said, within a disk, things condense and collapse, and that forms the planets. But on the edge of the disk, there's no reason why that should end at the outermost planet. Instead, further out, you've sort of got the leftovers. You get rubble. You get small things forming. And so we should expect a belt of small icy bodies on the outskirts of the solar system. That was 1943. A little while later, an American astronomer, Gerard Kuiper, realized that such a belt would provide a reservoir for the comets. And unlike his predecessor, Kuiper thought that Pluto was probably one of these things, but worried about the fact that we'd only got one Pluto. Nonetheless, there's beginning to be an idea that there is, on the edge of the solar system, what the Irish call the Edgeworth-Kuiper Belt. Everyone else calls the Kuiper Belt. I found that out to my cost lecturing in Dublin. But this belt of small icy bodies around the space that Pluto is occupying. On the other hand, people are discovering throughout the 20th century that Pluto is more interesting than they expected. In 1988, Pluto passed in front of a star, and it was observed by telescopes all around the world, and in particular by a telescope on board this thing. This is the Kuiper Airborne Observatory. That hole at the front of the plane behind the windows is actually a hole that a telescope was pointed out of. So you can get above the Earth's atmosphere and make observations. And in this case, you can chase Pluto's shadow and observe this occultation, this passage in front of the star. And what they were trying to do was measure the size of Pluto. Because if you can time the point where the star disappears and when the star comes back, that gives you a size. But what happened was the star dimmed slightly at the beginning. And then when it came back, it didn't blink back into existence, it came back slowly. And so what that tells you is there's an atmosphere. So like a proper planet, Pluto had an atmosphere. Observations from the ground. This is the UK Infrared Telescope in Hawaii, which we've now sold to the University of Hawaii. But in the 1980s as well, they were able to get a spectrum and tell us what Pluto was made of. And it was made of nitrogen ice. So it's not a gas giant. It's not like Uranus and Neptune. It's an icy ball. That explains its color. So we have an ice ball on the edge of the solar system with an atmosphere. But we still don't know the crucial question, which is how big is Pluto? They've got some idea of size at this point, but how massive is Pluto is the real question. Is it massive enough to impact Uranus and Neptune, to do the thing that it was found to do? That question began to be resolved in June 1978, when James Christie, an astronomer at the US Naval Observatory in Washington, D.C., was looking at images of Pluto. In fact, these images of Pluto, which were taken a few months earlier from a telescope in Arizona, just a few miles from where Pluto had been discovered. These look a mess, right? This is not what you want your nice images of the sky to look like. And cleverly thought about throwing the whole lot away. But he was about to go on a week's holiday. And he didn't have anything else to do that afternoon. So he thought he'd think about these images and started to measure the position. And he realized that there was this blob that you can see on the left, right? There are two blobs here. It's extended towards the top. And he realized that this was visible in several images taken over the course of several weeks. And his first thought was that this could be a volcanic eruption or something like that, sending material high up above Pluto's surface. But then he realized that seems unlikely that an eruption would last for a month. The word month made him think about moon, and he realized this could be a moon of Pluto in orbit around it. And he measured carefully its orbital period and found that it went round Pluto every 6.4 days, so very close in. Christie knew that Pluto changed brightness every 6.4 days on a regular pattern. And he realized he'd discovered a moon in orbit around Pluto. He tried to name it for his wife. He wanted to call it Charlene, which I think would have been great. Can you imagine a solar system where we've got George the planet and Charlene the moon? I think it would have been great. He was told he wasn't allowed to name it for his wife, so he cunningly adopted a bit of mythology and went for Chiron, who's another god of the underworld, but he pronounced it Sharon. So it's a bit like Charlene. And so whenever we talk about the moon of Pluto, Sharon, I get letters from people who say, I don't know ancient Greek. Now that's true, but this one's deliberate. It's deliberately mispronounced for the discoverer's wife. Now once you've got a moon, and it took a few years, but by 1990 we had images from the Hubble Space Telescope that showed the moon separate from Pluto. Once you've got a moon, you can use the laws of gravity to weigh Pluto. And the results were surprising. So it's clear from these observations, from the discovery of the moon, that Pluto is smaller than the moon. It's a diameter of less than 1,500 miles across, and it's got a mass that's a 400th of the Earth's. So it's much smaller and less massive than the moon. In fact, contemporaries at the time, I found this while researching this lecture, this is a diagram from a genuine paper from a guy called Dressler, who normally studies galaxies. This is the mass of Pluto over time. And this paper was published in 1983, and he predicts that Pluto will disappear by 1984. Which it didn't. But it gives you an idea of the dramatic difference between the sort of 10 times the mass of the Earth object that astronomers thought they were looking for, and this tiny object on the edge of the solar system. Pluto isn't massive enough to affect the other planets. It's not massive enough that you'd count it. If you put it in the asteroid belt, it would be a large asteroid, but it would just be an asteroid. It wouldn't stand out. This, by the way, is the best map we had of it at the time from the Hubble Space Telescope. So there's clearly something going on the surface, but not much else. So now we've got an object that's really not very large, not very massive, but it is on its own at the edge of the solar system. It's not like anything else. And that was true until 1992, when David Jewett, a Londoner who moved to the US, and Jane Liu, a Vietnamese-American astronomer, found this thing, circle added later. This is 1992 QB1, recently called Albion, but everyone I know still calls it QB1. And in some sense, Jewett and Liu were doing a braver thing than any of the people who'd looked for Neptune or Pluto. They were doing a blind search of the sky, taking the advantage of new CCD technology, the cameras that are in your phone, to take faint images of the sky and perform this old trick of looking for things that move. And they found a companion, something else out on the edge of the solar system, a second member of the Kuiper Belt. And their success inspired others. And the number of Kuiper Belt objects climbed quickly over the next couple of decades, to the point that by 2006, there were thousands of these things. In fact, we now know of nearly 4,000 objects out near Pluto, and some of them are fascinating and interesting worlds. An interesting one, for example, found in 2003 is an object called Sedna. Sedna is one of the reddest objects in the solar system. It's nearly Mars-colored, and it's on this long elliptical orbit. It takes more than 11,000 years to orbit the sun. We, not by coincidence, happened to find it when it was near the sun, at the position indicated on the right here. That's our best image of it on the left. There will now be some blobs, by the way, for the next few minutes, but there are some good images coming. So this is an unusual thing. Haumea was a controversial discovery announced in July 2005. This is an image of it. It's got a couple of moons, which is why it changes brightness, as seen in the graph. And people think that maybe it's a rotating oblong like this. It may have rings as well. In fact, it does seem to. So it's possible that this was an object that was involved in a collision with other objects. It goes around every 284 years. And then this one, also announced in 2005, though discovered in images taken in 2003. This is Eris, which is the god of discord, and Dysmomia, her daughter, is the god of lawlessness, a large Kuiper Belt object and its moon in a highly eccentric 558-year orbit. This one comes within the orbit of Pluto, but the crucial thing is that it seemed from the observations taken at the time that it was at least as big and as massive as Pluto. Actually, it is more massive, though it's very slightly smaller. And for a time, this was referred to, in 2005, as the 10th planet, a notion encouraged by one of its discoverers, Mike Brown, who wrote a book called How I Killed Pluto and Why I Had It Coming. It's very much representing one side of the debate this evening. But it was really the discovery of Eris, as well as the large number of other Kuiper Belt objects, as we'd now say, or trans-Neptunian objects, that made people realize that made the IAU decide that something needed to be done. In fact, there's a huge number of these things now known, and you can see that there are 5 to 10 large things from Pluto. I've mentioned Eris, Haumea, Makemake was discovered at the same time as Eris. Gong Gong is another interesting red object found in a search for Sedna-like surveys by a team, including Meg Schwamm, who's in the audience tonight. So I wanted to call out Gong Gong. What's interesting about Gong Gong is that it's incredibly dark. It seems to have methane, perhaps, on its surface, and it's as well as, like many of these objects, a moon as well. So you can see why in 2006, when people are claiming a 10th planet and potentially 11th and 12th and so on, that people decided that there needed to be a definition. At this point, the International Astronomical Union more or less bungled things. They set up a committee. It consisted of 5 astronomers, a historian, and a science writer. And the Committee on Planetary Nomenclature came up with this definition. They said a planet is a celestial body that A, has sufficient mass for its self-gravity to overcome rigid body forces, so it assumes a hydrostatic equilibrium or nearly round shape. Basically, this is encoding the idea that we think planets are big. And it turns out that if you're big, this is true of people as well as planets, you become rounder. And if you reach a particular mass, depending on what you're made of, then gravity will force you into a round shape. Now, not completely round because you'll be rotating and so on, but basically you become round. So your potato-shaped asteroids don't count. Planets need to be massive. We can use the fact they're round to filter for the small stuff. And then B, you should be in orbit around a star. You should also not be a star, because there are double stars in the universe, and nor should you be a satellite like the moon. And so this seemed sort of sensible. It would have made Pluto a planet, probably a double planet if you count Charon. It would have made Ceres, the largest asteroid, which is round, a planet. So that's what? Pluto, Ceres, anyone, so that's 10. But contemporary estimates said that there would be about 50 to 200 of these things, starting with Eris, in the outer solar system. So by this definition, there would have been hundreds of planets in the solar system. How you feel about that, I think, depends on what kind of person you are. And the committee helpfully said there were 3 kinds of definition. You could think about dynamical definitions, so basically based on how you move in the solar system. Are you on a distant orbit? Are you orbiting a star or a planet? This is sort of the way that astronomers tended to think. There were geological definitions, like do you have landscape? Do you have a surface that geologists are interested in? That's what planetary scientists tend to think about. And then there's the cultural option, which I think if the IAU had chosen cultural, this would be easier, where you just say, look, there are traditionally 8 or 9 planets, live with it. But instead, they try and come up with these definitions. No one liked this definition for some reasons that make sense to me, like, do you really want to learn 200 planets? And some which don't. People were very upset that the moon is moving away from the Earth. And so at some point, perhaps, it would need to be considered its own planet, even though nothing would change about the fact about the moon. Or if you have a planet and it's expelled from a star system, in this definition, it ceases to be a planet. These are the kind of things that upset people. And so everything came down to that vote on the last day of the meeting. And to give you an idea of the seriousness with which this vote was taken, I'm going to show you a genuine picture of my friend and colleague Jocelyn Bell-Burnell, who studies pulsars rather than planets, but who was chairing the session. And this is her attempt to explain the issues that they were dealing with. So as you can see, the definition that we're trying to come to has to decide what lives in the planetary umbrella. And your options are big blue things like Neptune, Pluto, and small things like, for some reason, a box of Crunchy Crisp cereal. Remember, this was broadcast live on television as a scientific debate. What got passed is this. A planet's a celestial body that is in orbit around the sun. So this doesn't help us if we want to argue about planets in other systems. We'll worry about that later. Has sufficient mass to be round, and then has cleared the neighborhood around its orbit. So this is a compromise, and the idea here is that you have to be the largest thing around. So, for example, Mars and Jupiter count, and the asteroids don't. Neptune counts. Has Pluto cleared its orbit? Well, there's all these other Kuiper Belt bits, and it crosses Neptune's orbit. So you can argue that it has not. And in fact, the resolution went on to say, look, there are actually two types of things. There are 8 planets, and there are the dwarf planets. Created this category of dwarf planets, which it explicitly says are not planets. Ceres, Pluto, Eris, and then you can add in maybe Haumea, Makemake, and lots of the other ones. This upset people. They upset people, I think, because change is hard, right? We learn, lots of us, that Pluto was a planet in school, and we don't like uncertainty. We also, I think, don't like the fact it's very hard to explain this definition. What does cleared its orbit mean? It doesn't have a scientific meaning. It's a sort of made-up phrase. You sort of know what it means. But for decades now, 2 of them, people have continued to get upset by this. And you find Pluto in all sorts of strange places. So for example, I'm sure many of you are familiar with the Korean pop group BTS. They have a song called 134340. This was the asteroid number that was given to Pluto. It's a symbol of its demotion. Planets don't have numbers, asteroids do. 4937 is Lintott, 134340 is now Pluto. And the song, I mean, I'm going to do a loose translation from the Korean, but this is in detail. They say, could it be really that you found Eris? Tell me, how am I not as good as that moon? Us is the plural form of you, and maybe I wasn't there from the start. Someday you'll always understand my words. My seasons were always you. My cold heart is 248 degrees below zero, which is the correct temperature for Pluto at the time. It stopped the day you erased me, damn. And it goes on. There are many verses. The point is, I think, that this is both upsetting and complicated. Because this is actually a sense of where we are in the solar system. This is a Euler diagram, or a complicated Venn diagram. So you've got planets in the top left. And then there's a mess of everything else. So there are trans-Neptunian objects, which are beyond Neptune. Some of those are dwarf planets, but not all of them. And then there are minor planets, some of which are dwarf planets, some of which are not. There's the catch-all category of small solar system bodies. There's obviously the things that are satellites or moons. Comets are icy. They're small, and some of those are minor planets, but not many of them, and so on. This is a mess. And what people crave is simplicity. This is a 1991 stamp set from the US Postal Service that shows the then 9 planets. Mercury, Venus, we've got Earth, we've got Moon added, Mars, Jupiter, Saturn, Uranus, Neptune, all with spacecraft, and then this is 1991, so that says Pluto, not yet explored. And that stamp was on board a spacecraft that launched in January 2006, a few months before Pluto was demoted, carrying a spacecraft called New Horizons that swung past Jupiter, taking amazing pictures, and heading out to see Pluto up close for the first time. The New Horizons team, or to be fair to them, as I know lots of them, some of the New Horizons team took Pluto's demotion really personally. This is the logo of the New Horizons mission. It has 9 sides, because Pluto is, of course, the 9th planet. The team developed a special salute that they used, embarrassingly, in press conferences, which was something like this, which, of course, is 9 for the 9th planet. And I remember at the point where their spacecraft flew past Pluto, them celebrating with a giant copy of the stamp, and if you can't see it, they've crossed out "not yet explored," and it now says "explored." That's Alan Stern in the front left, the charismatic and brilliant principal investigator, who's Pluto's main defender. Now, New Horizons was an incredible mission. It flew past Pluto in 2015, passing quickly through the system and imaging Pluto, Charon, its largest moon, and 4 other small icy moons that have been found since. It took 15 months to get all the data back to Earth, but even the original images that came back were absolutely stunning. This is the close-up of the hemisphere of Pluto that New Horizons saw best. And you can see instantly that this is a complex and fascinating world. It has a variegated surface. There's this dark material along the equator, which seems to have been deposited perhaps from interactions with the moon Charon. And there's this smooth area, Sputnik Planitia, which is perhaps a giant impact basin where something maybe 4 billion years ago hit Pluto. And then the basin has been filled in and is repeatedly filled in by either movement of nitrogen ice on the surface or perhaps even snow condensing from the thin atmosphere to refill this. You can see there are areas with many craters. They must be old, but there are also areas that are smooth, which have therefore been resurfaced in the last few 100,000 years. There are mountains on Pluto made of frozen water ice, and even the possibility of moving glaciers and even ice volcanoes. It's an incredibly beautiful and unusual world. I was lucky enough to report on this, and I remember my now colleague Carly Howett, seen here at the time, coming down from an all-night session where they produced this image of the world of Pluto. And we just sat there in awe for a couple of hours trying to work out all the things that this told us. Remember, before New Horizons, the best image we had looked like the top, and suddenly we now had a map of an unusual world. There's all sorts of stuff going on. We've got this impact basin that's filling up. If you look closely on some of these images, you see it split into cells where there appears to be upwelling of material, so there's some sort of cryovolcanic process going on. The close-up images are even better. The one on the left here was taken 15 minutes after the closest approach. So the sun is just setting behind Pluto, and you're seeing here water ice mountains rising 3.5 kilometers above Pluto's surface. No one knew that we'd see this sort of thing, and the idea of such complex formations on this world were unexpected. The atmosphere too was uniquely complex. It has these hazy layers. If you can see, there's these thin stripes just above the planet's, the world's, or above Pluto's. See, I meant to drop that in deliberately at some point, but above Pluto's surface. And these hazy layers, they seem to be caused by the interaction of hydrocarbons, of methane and things like that with UV light from the sun. But why they're in layers and how you form this is still a mystery. And Pluto was supposed to be losing its atmosphere. One of the reasons that people wanted to get there as soon as possible was that as Pluto swings out into the outermost bit of its atmosphere, it was expected to freeze out. But the loss of atmosphere was much, much less, 10,000 times or so less than expected. And so images like this one, taken as the probe was heading off into the distant solar system after a very brief visit to the system, as well as beautiful, are scientifically fascinating because they tell us about the processes that are happening in this atmosphere. People will be studying data from New Horizons, well, until we next send a probe out to Pluto and this fascinating world. So you can see that if you're an astronomer thinking about points of light moving in the solar system, maybe it makes sense to put Pluto in the non-planet category. But if you're thinking about the physics of the solar system, if you think about the processes that shape our planet, Mars, the icy moons of the outer planets, and Pluto, those are the same thing, and it doesn't make any sense to separate out Pluto. We didn't demote Pluto because it wasn't interesting. We demoted it because we thought of it based on its orbit, not as the world that New Horizons revealed it to be. So why then, to finish, why did, apart from a general love of rabble-rousing, did I call this lecture Pluto Isn't a Planet? Well, I don't think we can claim that it is, because essentially there are three kinds of thing in the solar system. And there's an astronomer in California, Jean-Luc Margot, who has argued this strongly. And he just says, look, plot the distance from the sun of everything and the mass of everything on this plot. So this is the whole solar system without the small stuff. And you've got the four big planets in the top right. No one would argue that they're not planets. Then Earth, Venus, Mercury, and Mars, they're close in, they're reasonably massive, they form a group. Everything else lies below this line. And so really there are two kinds of thing in the solar system. There are the big planets, and then there's everything else. And Pluto is the largest, if not the most massive, of those objects. It's the king of the small things, not the ninth member of the Planet Club. And I think that's true. I genuinely believe that. Where I don't agree is that Margot and co. say, okay, we just need a better definition. So their suggested definition includes the fact that you've got to be a planet, you have to have sufficient mass to dominate the neighborhood around its orbit, which means a planet mass of greater than 0.001 times 2 times the solar mass times to the eighth planet, multiplied by your semi-major axis to the eighth power, and you've got to have a mass ratio which is greater than this complicated fraction. Like, this doesn't help anyone. We're not going to get anywhere having a more complicated definition. The solar system has lots of stuff in it. And we need to be reminded, I think, that the story of Pluto, both the story of its discovery, which was due to luck, the story of the 76 years in which it was a planet and which people struggled to find out about it, even though we could only ever see it as more or less a point of light, and the fact that it's led us to this fascinating place with all these strange worlds on the edge of the solar system. This needs to remind us that there's more out there than we imagine. This image was sent to me when this talk was advertised. I got an email from Todd Lauer, who I've mentioned in previous talks, who's a member of the New Horizons team, and he said, "I'm sorry to hear about your lecture." Sorry, Todd, I hope you're watching. And he said, few people have seen this image which we produced. This is an image taken by New Horizons leaving the Pluto system. The sun is off to the far right. So at the top left, what you've got is the night side of Pluto illuminated by glow from its hazy atmosphere. And in the bottom right, you've got Charon, the moon, no atmosphere, so a barren, icy surface, but it's shining based on Pluto light. So a full Pluto on Charon gives about an order of magnitude more light, so it's brighter than the full moon is for us on Earth. And that description of this evocative shot showing two bodies just hanging in deep space, I think, tells me much more about this place and these bodies, and gives me much more of a thrill than arguing about whether it's a planet or not. And so I urge you, next time somebody waves a Justice for Pluto t-shirt in your face, or a placard, or tells you that astronomers don't know things, don't worry about whether this is a planet. Think about this world hanging in deep space, and hope that sometime soon we'll get back and explore it and the rest of the Kuiper Belt as soon as possible. Thank you very much.
Chris, thank you very much. Now, we do have some time for questions. Is it possible to turn the main lights up and the spotlights down a bit? Otherwise, Chris and I can't actually see who's waving.
I can also see anyone storming the stage then, so that would be helpful.
Right, we've got a question down here. So Angela's got the microphone.
There's a mic coming down slowly. Sorry. It just feels like a long time for whoever's about to ask a question.
Voyager is approaching its 50th anniversary. Could you talk a little bit about its achievements, and do it and New Horizon make a strong case of unmanned versus manned missions?
I will duck part of that because it would take several lectures to talk about the Voyager missions, for sure. So they, of course, were the great explorers, building on the pioneers of the outer solar system. And in particular, you know, Voyager 2, which went not just to Jupiter and Saturn, Uranus and Neptune, and taught us about things like the moon of Neptune, Triton, which has lots of Pluto-like characteristics, and yet is fascinatingly different. One fun result from Voyager, and I will use the question to tie up a loose end, is that in 1993, there's this paper from Miles Standish, who points out that Voyager 2 in pink, this is the route it took through the solar system, passing Uranus and then Neptune here. He uses this trajectory to calculate the masses of Uranus and Neptune. And it turns out that anomaly that people were trying to resolve with Pluto, we got the mass of these two things wrong. We got their composition wrong. So one of the effects of Voyager was that we realized that the problem that we were trying to solve didn't exist at all. So there was no need to search for Pluto. I think the other thing to say about Voyager and New Horizons is that they show how much information you can get out of a flyby mission. So neither of these missions went into orbit around their target. It would be too expensive, basically, to launch New Horizons with enough fuel so that it could break and go into orbit around Pluto. So it was only there for a few hours, and yet we've had a decade's worth of exploration of that data, and people are still working on the Voyager data. So I think they encourage us to go to the outer solar system, even if we can't stay. And it would be great to have a fleet of such things repeatedly visiting these fascinating worlds.
We're going to hop to an online question. So Katsia has asked, what are the main arguments of people who still consider Pluto to be a planet?
So I think they would say there's three types. The sensible one is it has planetary processes. So if you care about the physics of what shapes planets, everything that occurs on Earth, plus a few exotic things, happens on Pluto. And so they would say it makes no scientific sense to arbitrarily divide those two things up. I think that's a reasonable position. Another one is a sort of cultural, like it was a planet, so why not just say there was 9? I'm okay with, or maybe you're happy that there are 200. That seems okay. That's a choice. And then the third one, my favorite, belongs to the New Mexico state legislature, who by law have decreed that whenever Pluto is in New Mexico airspace, it shall be considered a planet. And so if you're watching this in New Mexico, I'm not sure what the fine is for breaking such a law, but because Clyde Tombaugh moved to New Mexico and worked there for many years, they consider it their planet.
Right. You've actually probably answered one of the other online questions, which was, what's the significance of the photograph?
Oh, well, there you go. Yeah.
Shall we take another one in the room? Andrew, do you want to pick a question for us?
Hello. Would you consider that perhaps Pluto is trying to hide, given that that's the theme throughout the ancient astronomical myths across cultures?
Yeah, well, it certainly didn't make itself easy to find. And in fact, that's the thing, you know, you can ask how lucky Clyde Tombaugh got, and the answer is very, that Pluto happened to be there. We still argue about what's still out there to be discovered. Mike Brown, who led the teams that discovered many of the early large Kuiper Belt objects, believes that there's another large planet out in the outer solar system, a view that's deeply controversial, by which I mean lots of people think he's wrong. But nonetheless, there is this possibility that there are other large planets, and there are at least a few and maybe many large Kuiper Belt objects still to be discovered. So I'm not sure they're trying to hide, but they're certainly difficult to find. And I think there is this sense of these things on the edge of the solar system in deep space that's endlessly intriguing.
I'll take another online question from Ibrahim, who has asked, why doesn't Pluto orbit in the same plane as the other planets?
Yeah, it's a really good question, and we don't actually know the answer, but it's very clear that Neptune had a strong influence on Pluto. So in other lectures, I've talked about the fact that we now think that in the early solar system, things were a lot less stable. And in fact, the giant planets, Jupiter, Saturn, Uranus, and Neptune, will have migrated outwards And that has a dramatic effect on the outer solar system. So we think that for every Pluto that survived, there may have been 100 or even 1,000 that were lost to interstellar space because they were scattered by these giant planets. Pluto survived because it's in an interaction with Neptune. It hit this point where it goes round twice for every 3 times Neptune does. And so that may have protected, but it may also have excited it out of the plane. So I think it's Neptune's fault, but the details are really fuzzy.
I'll take one last one online, then we'll do one final one in the room. Last one online, Bill's asked, is this proof that astronomers shouldn't be allowed to name anything?
Oh, yeah, I think that's... I've been a strong proponent of that position for a very, very long time. Though I like Pluto's a good name, I think. So maybe 11-year-old school kids in Oxford should name everything.
Okay, and we'll take one final question in the room over here.
Thank you. Going back to the approved definition of a planet that was decided by people waving bits of paper in a conference room, has cleared the neighbourhood around its orbit.
Yeah.
You mentioned that one of the reasons that discounts Pluto is because it crosses Neptune's orbit. Doesn't that always discount Neptune as well?
Yes, exactly. This is why it's not... I mean, this definition has, I think, the feel of being written at 3 a.m. by a bunch of frustrated people stuck in a Prague conference room. And in fact, one of the members of the original committee was asked afterwards what they thought, and they said, "Thank God it's over." So I think this is the problem, and you know, I was slightly rude about Margot's definition here, but what he's trying to do is make this a sort of quantitative thing, and it essentially says you should be the largest thing, or at least you should have a mass large enough that you would have absorbed most of the material in the disk in which you were forming. So one can put it on a more scientific basis, but I agree that's one of the reasons I don't think the definition is satisfactory, even if I don't think Pluto's a planet. But just to be clear, I don't think we should rewrite the definition. I think we should just say, look, there are 8 largish things in the solar system, and then there's loads of other interesting stuff to look at. Just before we end, I did want to advertise 2 more forthcoming attractions in Gresham for the start of next year. So one is I managed to postpone one of my lectures because a telescope wasn't ready. So we'll have the latest results, including potentially some interesting stuff from the solar system for the Vera Rubin Observatory on September the 14th. Keep an eye on the Gresham website. And then we're going to have our first ever Festival of Astronomical Ideas, discussing with my fellow professors the connections between astronomy, archaeology, music, information security, biology, and the oceans, I think, on September the 25th. So please put those in your diary, and see you all next year.
And ladies and gentlemen, please join me in thanking our lecturer this evening, Professor Chris Lintott.
Thank you.
Thank you very much, Chris.
Thanks.